welcome everybody. We're jumping into our direct instruction part of our lesson. We're going to start by working on a problem that will hopefully help you gain an understanding of what equivalent ratios are. So the problem as it laid out, as you can see in your texts, it goes as follows. A cafeteria worker who knows that it takes 3 bottles of juice to serve a table of 18 students. How many bottles of juice are needed for 24 students? How many bottles of juice are needed for 42 students? So, Jose, what are some of the relevant numbers that popped out at your head when you heard the problem?
Okay, well, I know that we have 3 bottles of juice.
Okay, I've got 3 bottles. What else did you see in there?
We also know that there's 18 students.
18 students, right? Okay, so so are those are our knowns?
Yes, that's what we do know.
Right. And so the next step is to figure out what we don't know, right? So the first question, how many bottles of juice are needed for 24 students? So to look at this, we see that our first ratio is pretty straightforward. 3 bottles for 18 students. And our second question is, how many bottles of juice do we need for 24 students? So the first way we're going to approach this is to picture it. So we're going to talk about students as they pertain to juice. So to get to my 3 bottles of juice, my bottles of ketchup that look like bottles of juice, so we have 3 bottles of juice. We're picturing it, right? And then how many students do we have?
18.
Right? So we'll just do the circles. So the initial way we can look at this is we can do it 2 ways. We can look at the way the picture sets up, or we can do basic math. The basic math we would do is to reduce our unit rate to 1. Actually, we want to reduce to our related rate.
Yes.
We want to reduce our related rate to 1. So a simple way to do that would be to take 3 out of both of these. So if I do that, take 3 out of both, I get a ratio of 1 to 6. And if I look for reinforcement to that, I look at my picture here. My picture shows me I have 1, 2, 3, 4, 5, 6 students for every 1 bottle. Another way to demonstrate this is a graph. So in our math problem, we found out that our ratio is 1 to 6. So the first is bottles, and then students. Oops, I stole your paper. So one bottle is 6 students. And if we work out that ratio as it continues, first thing I'll do is I'll multiply by 2, then times 3, and I'll work my way up so I can get my unknowns. So at the second bottle, I get to 12 students. My third bottle is where I started, gets me to 18 students. My fourth bottle gets me to 24 students, which is one of my unknowns. Then I could keep doing it as a logical progression, or I could apply the ratio to my other unknown, which was 42. So to continue on the pattern I have though, it's 5 and 30, 6 and 36, and 7 and 42. And therefore we see how to get to 42 students getting juice.